Hey everyone, welcome back. Ready for another deep dive?
Always.
Awesome. So today we're going to tackle some pretty big questions in astrophysics.
Oh, sounds right up our alley.
Right. And lucky for us, we've got this fantastic article featuring insights from, well, the legend himself, Neil deGrasse Tyson.
Can't go wrong with some Neil deGrasse Tyson wisdom.
Definitely not. We're talking photons,
Mhm.
gravitational waves, black holes, even the fabric of space-time.
The whole shebang. You know, it's pretty amazing how these concepts are all kind of woven together. Like, when you start to understand one, it really opens up the others.
Totally. It's like you pull on one thread and this whole incredible tapestry of the universe starts to unfurl.
Exactly.
All right, well, let's start with something we all experience every day. Light. Seems simple enough, right? But when you really stop and think about it, what is light?
Ah, the deceptively simple question with a mind-blowing answer. Well, our article uses a great analogy here, a burning candle.
Okay, I can picture that.
So you strike a match, the flame ignites the wax, and boom, there's this whole chain reaction happening down at the atomic
At
level.
the atomic level. Whoa.
Yeah, the energy from the flame gets those atoms in the wax all excited. Their electrons jump up to higher energy levels, and then when they fall back down, they release energy. And guess what that energy is released as?
I'm going to guess photons.
Bingo! Tiny little packets of light energy.
So all those flickering flames are actually shooting out tons of photons into the room.
Precisely. And this whole process, it's not just with candles, right? Think about the stars. They're like giant cosmic candles burning all the time, emitting just a crazy number of photons. Like our sun, in just 1 second, it releases more photons than there are grains of sand on every single beach on Earth.
No way.
Yeah.
I can't even wrap my head around that. So every time we look up at a star, we're actually seeing a flood of these photons that have traveled, what, millions of miles across the universe?
Millions and millions, sometimes even billions. It really makes you realize just how active and energetic the universe truly is.
It really does. Okay, speaking of energy, let's shift gears a bit. Talk about something even more powerful. Gravitational waves.
Ooh, yeah.
I remember back in 2015 when scientists announced they'd finally detected them. It was huge news.
Oh, absolutely groundbreaking stuff.
But I gotta be honest, I'm still a little fuzzy on what gravitational waves actually are.
All right, well, picture this space-time. It's like a giant, flexible fabric, kind of like a trampoline. I know, it sounds weird,
Yeah, a little bit.
but stick with me. So, massive objects like stars and black holes, they create these like dents in this fabric, and those dents, that's what we experience as gravity.
Okay, I'm starting to see it.
Now, when these massive objects move around, they create ripples in the fabric of space-time. And those ripples, they travel outwards at the speed of light, and those are gravitational waves.
So like if you drop a bowling ball on a trampoline,
Mm.
everything around it kind of like warps.
Exactly. It's mind-bending stuff, but that's how the universe works. And the really amazing thing is that we can actually detect these waves now. We've got these incredibly sensitive instruments called interferometers.
Interferometers.
Yeah.
Catchy name.
Right. And by studying the patterns of these waves, we can learn so much about the objects that created them, like their mass, their spin, even the details of how they collided.
So we're not just seeing these cosmic events with light anymore. We're actually hearing them, too, through these gravitational waves.
You got it! It's like the universe is speaking to us in this whole new language.
This is seriously blowing my mind. So we've got this fabric of space-time. It can bend, it can ripple. Could it actually RIP? Like, what would happen then?
Whoa there, hold on. That is a seriously fascinating question, and it actually leads us to this pretty unsettling theory called the Big Rip.
The Big Rip. Sounds ominous.
It kinda is. The idea is that the universe, which we know is expanding, could actually speed up that expansion to the point where it tears the fabric of space-time apart. Billions of years from now, though.
Oh, okay, good. Billions of years. Plenty of time to process that thought. It's just wild to think about how dynamic the universe is, on a scale we can't even begin to fathom.
No kidding. And these dramatic events, they aren't just limited to, like, the fabric of space-time itself. Let's zoom in a bit, get a little more tangible. How about the death of a star?
All right, now we're talking supernovae. It's like the universe's grand finale fireworks show, right?
Absolutely. Spectacular, but also the end of a star's life. But then the question becomes, what happens after a supernova? What's left behind?
Yeah, that's a good question.
Well, there are a couple of possibilities. If the star was relatively small, like our sun, it'll leave behind this super dense thing called a neutron star.
Okay, a neutron star, got it.
But if the star was really massive, its core, it'll collapse under its own gravity, forming something even crazier.
Even crazier than a neutron star.
Oh, yeah, a black hole.
Black hole. Just the name sounds intimidating.
They kind of are, but also seriously fascinating. So a black hole, it's basically a region of space-time where gravity is so strong that nothing, not even light, can escape.
Whoa, nothing. Not even light.
Nope. Remember that trampoline analogy? Well, imagine you dropped a bowling ball so heavy it punches right through the fabric. That's essentially what a black hole does to space-time. It creates this infinitely deep well that warps everything around it. Anything that gets too close is just sucked in.
So even though the star itself is gone, its gravity is still there, warping space-time in the form of this, like, hole.
Exactly. Pretty spooky, huh?
A little bit. It also makes me wonder, are black holes just giant chunks of dark matter?
Ah, that's a common misconception. And the answer is a big, fat no. Black holes and dark matter, they are totally different things.
Hold on, I'm getting a little lost. Could you break that down for me?
Sure. So black holes, they're formed from the collapsed cores of massive stars. They're made of regular matter, the same stuff that makes up you and me. It's just been squeezed down to an insane density.
Okay, makes sense.
Dark matter, on the other hand, it's something else entirely. It doesn't interact with light at all, which is why we can't see it. We only know it's there because of its gravity, how it affects things like stars and galaxies.
So it's like black holes are the leftovers from this huge cosmic feast, and dark matter is the mystery ingredient that we know is there, but we can't quite figure out what it is.
That's a great way to put it. And the true nature of dark matter, well, it's one of the biggest mysteries in astrophysics today. We know it's out there, lurking in the shadows, but what it is, how it works, that's still a huge puzzle.
Okay, my brain is officially buzzing with all this cosmic info. Maybe we should bring things back down to Earth for a sec. Speaking of Earth, our article mentioned something about tides that I found really surprising.
Oh yeah, what's that?
It said that the sun's gravity also affects the tides. I always thought it was just the moon.
It's easy to think that, right? But the sun's gravity does play a role too. It's just that the moon's pull is much stronger because it's so much closer.
So how does that work? Like, how do the sun and the moon both affect the tides?
Well, imagine the Earth as this giant ball of water. Now, as the moon orbits us, its gravity tugs on that water, creating this bulge, a high tide, on the side facing the moon.
Makes sense. But wait, you said there's also a high tide on the opposite side of the Earth? How does that happen?
Ah, that's where things get really cool. It's not just the water the moon's pulling on, it's also tugging on the Earth itself. So the Earth actually bulges out a bit on both sides. The bulge facing the moon is from the direct pull, but the bulge on the opposite side is from inertia. The Earth's trying to resist that pull.
So it's like a cosmic tug of war.
Exactly. And then you throw in the sun's gravity. It's much weaker because the sun's so far away, but it's still there. And when the sun and the moon line up just right, their combined gravity creates these extra high tides called spring tides.
Whoa, so the tides we see here on Earth are a direct result of this whole intricate dance between the Earth, the moon, and the sun.
Yep. It's a reminder that we're all connected, not just here on Earth, but within this vast cosmic web of the universe.
Okay, I gotta admit, I'm starting to feel a little small and insignificant compared to all this, but in a good way, you know? It's like humbling and awe-inspiring at the same time.
I get that completely. Studying astrophysics, it often makes you feel that way. A sense of wonder and, yeah, a bit of humility, too. There's just so much out there that we still don't know. So much left to discover.
Well, on that note, I think we need to take a little break, let all this cosmic knowledge sink in.
Good idea. We've covered a lot of ground.
We have. But when we come back, we'll keep exploring these mind-blowing astrophysical concepts, and maybe even unravel a few more of the universe's secrets.
Stay tuned.
All right, we're back. I gotta say, I'm still kind of reeling from all that talk about black holes, punching holes in space-time.
It's definitely one of those concepts that just, stretches your brain a little.
Yeah, it really makes you question everything you thought you knew about, well, reality.
Absolutely. Speaking of things that challenge our understanding of reality, let's circle back to those tidal forces we touched on earlier. Remember we were talking about how both the sun and the moon influence the tides here on Earth.
Yeah, I've always been curious about how that works.
Mm-hmm.
Like, I get the moon's gravity pulling on the oceans, but the sun's influence always seemed a little more, I don't know, subtle.
It's a bit more complex,
Okay.
yeah. But picture this, the Earth. It's this giant sphere covered in water. Now, as the moon orbits around us, its gravity tugs on that water, creating this bulge, a high tide, on the side of the Earth facing the moon.
Right, okay, that part I get.
But then there's also a high tide on the opposite side of the Earth, too. Ever wonder why that is?
Now that you mention it.
Yeah.
Yeah, actually, I have. How does that work? If the moon's pulling on one side, shouldn't the other side have a low tide?
That's what makes it so interesting. You see, it's not just the water the moon's pulling on, it's also pulling on the Earth itself.
Oh, wow, I never thought of it like that.
Yeah, so the Earth, it actually kind of bulges out a bit on both sides. The bulge facing the moon, that's from the direct pull of its gravity. But the bulge on the other side, that's actually from inertia. It's the Earth's tendency to resist that pull.
So it's like the Earth's being stretched.
Exactly. And then on top of that, you've got the sun's gravity.
Oh, right, the sun. I almost forgot about that part.
The sun's much farther away, so its gravitational pull is weaker. But it's still there. And when the sun and the moon line up just right, their gravity combines to create these extra high tides. We call them spring tides.
Wow, spring tides. I've heard of those. So the tides we experience here on Earth are basically the result of this whole cosmic tug of war between the Earth, the moon, and the sun.
Exactly. And it's a pretty powerful reminder that we're all interconnected, not just here on Earth, but as part of this vast cosmic web. Like
Yeah.
when you look up at the night sky and see the moon and stars, you're not just seeing these points of light. You're seeing these active participants in the forces that shape our planet.
That's wild. I've got to admit, all this talk about cosmic forces is making me feel a little bit, well, small, like insignificant.
I get that. I think everyone who delves into astrophysics feels that way at some point. But it's not a bad thing, right? It's kind of humbling and awe-inspiring.
Definitely. It just makes you realize how much is out there, how much we still don't know.
Exactly. And that's what's so exciting about astrophysics. It's a field that's always evolving, always pushing the boundaries of what we know. Like right now, one of the most exciting areas of research is the search for exoplanets.
Exoplanets, those are what? Planets that orbit stars other than our sun?
Yep. And with telescopes like the James Webb Space Telescope, we're finding more and more of them all the time. Some of them might even have conditions that could support life.
Whoa, finding life on other planets. That would be incredible. It would totally change how we see ourselves, our place in the universe.
It would be revolutionary. And then there are all these other mysteries out there we're still trying to solve, like dark energy, for example.
Dark energy? What's that?
Well, it's this mysterious force that seems to be causing the universe to expand faster and faster. Like, we know the universe is expanding, but it should be slowing down because of gravity. But it's not. It's actually speeding up.
That doesn't make any sense.
I know, right? It's a total head-scratcher. The best explanation we have right now is that there's this unknown form of energy, which we call dark energy, that's pushing everything apart.
So it's like this invisible force that's fighting against gravity on a cosmic scale.
Pretty much. And we're still trying to figure out what it is, what its properties are, how it fits into our understanding of physics. It's one of the biggest mysteries in cosmology.
So basically, when it comes to understanding the universe, we've only just scratched the surface. There's so much more to discover, so many questions left to answer.
Absolutely. And that's what makes astrophysics so captivating, so endlessly fascinating. It's this constant quest to unravel the secrets of the cosmos. Every new discovery opens up new paths to explore, new mysteries to solve.
It's inspiring to think that we, as humans, are capable of understanding things like black holes and gravitational waves and, the expansion of the universe. It makes you appreciate the power of the human mind, to grasp these huge cosmic concepts.
It really does. And remember, our exploration of all these incredible ideas, it's just getting started. We've still got a lot more ground to cover, more mysteries to unravel.
I'm ready. What other cosmic wonders await us? All right, lay it on me. What other cosmic wonders are waiting to be explored?
Well, we've talked about space-time bending and warping around these massive objects, right?
Yeah, and it totally makes my head spin.
It's a seriously wild concept, but it leads to some fascinating possibilities. Like, have you ever heard of wormholes?
Wormholes, like those shortcuts through the universe. That's sci-fi stuff, isn't it?
It sounds that way, right? But here's the thing. While wormholes are still theoretical, Einstein's theory of general relativity, the math behind it, it doesn't actually rule them out.
So they could actually exist.
Which, in theory, yes. Like, imagine a wormhole connecting two distant points in space-time. You could, hop through and travel across vast cosmic distances in an instant.
Instead of taking millions of years to reach another galaxy, you could just, poof, be there.
Theoretically. Of course, we haven't actually found any wormholes yet, and there's still a lot we don't know about how they might form, how they would work. But the possibility is pretty mind-blowing, isn't it?
Totally. It makes you wonder what other crazy things might be possible with space-time. Like, I don't know, time travel, teleportation.
Exactly. The universe is full of surprises, and our understanding of physics, it's always evolving. I think the key is to keep an open mind, right? Never stop questioning.
Absolutely. That sense of wonder, that curiosity, that's what drives all scientific discovery. So we've explored photons, gravitational waves, black holes, the expanding universe, even touched on the possibility of wormholes. Anything else we need to cover on our astrophysics deep dive?
I think we've covered a ton of ground today. But there's one thing I want to emphasize before we wrap things up. All these seemingly separate concepts, they're all interconnected.
Like how understanding photons helps us understand stars,
Mm.
or how space-time warping is key to understanding gravity and black holes.
Exactly. It's all part of this grand cosmic web. And each new discovery we make, it helps us weave that web together a little more. It helps us paint a more complete picture of how the universe works.
Like piecing together a giant cosmic puzzle.
That's a great way to put it. And the more pieces we find, the more we realize how much more of the puzzle is still out there.
True. It's both exciting and a little daunting, isn't it?
It is. That's what makes astrophysics such an incredible field. It's constantly evolving, with new discoveries being made all the time.
I'm already hooked. Well, on that note, I think it's time to wrap up our astrophysics deep dive for today.
It's been a blast exploring the universe with you.
The feeling is mutual. And to all our listeners out there, remember to keep looking up at the stars, keep asking questions, and never stop exploring the wonders of the universe. You never know what incredible discoveries might be waiting just around the corner.
Until next time, keep those cosmic minds engaged.